Welcome CSC 121 to exercise 7. This is RGB hex conversion. We'll just call it RGB-hex. And before we get into it, I'm going to give you a quick lesson on hex numbers, hexadecimal number system. I'm going to try and do it with 10 comments here. Hopefully that'll be enough to learn about hexadecimal. And the first comment here says 8-bit numbers represent 0 through 255. You're probably familiar with that. Through RGB colors, we use 8-bit numbers to represent RGB numbers and RGB colors. So if there's a red, green, and a blue, we use an 8-bit number for each one. So we could have something like 25500 for red. We could have something like 02550 for green. We could have 128, 128, 128, and have them be all gray. They could be 000 for black, and so on. So we use those numbers for RGB. It's 24-bit because there's 3 8-bit channels. So you might be familiar with using that if you ever worked in a program that worked with color. And that's the way pixels are basically composed. Now, there's also something called hexadecimal number system. Now, they're not just used for colors, but they can be used for 8-bit numbers. And we are talking about 8-bit numbers, so we're only going to still be working with 0 through 255, except when they display the number, they only display 2 digits. They can't use 255. They have to use something else. Now, that's fine for smaller numbers. They're going to basically use a 16s place and a 1s place. So you basically say how many 16s there are and how many 1s there are in 2 digits. That's all you need to do. So it only uses 2 digits. And just for example, if you had the actual number 16 in decimal, the regular RGB number 16, there would be 116 and 0 ones. So in hex, it would be #10. We use the pound sign to indicate hex, even though we also use it for comments in Python. So that would be 10. It would be 116 and 0 ones. 116, 0 ones. That would be the hex number for that. So that was pretty easy. Now, if you have digits over 9, that creates a problem. So they actually use letters for 10, 11, 12, 13, 14, and 15 because you wouldn't need any numbers above 15 if you're sticking with 8-bit. So they only go up to 15 because the highest number you can make is 255. So again, the A is 10, the B is 11, the C is 12, the D is 13, E is 14, and F is 15. You just have to memorize that. So for example, the number 160 in RGB, the decimal number of 160, would basically be 160 divided by 16, which would be 10. Now you couldn't use 10, so you'd have to use A. So that would be A16s and 0 ones. So it would be A0 because there's 10 16s and 0 ones, which would be A16s. That's the way it works. And then finally, the highest number would be FF, which is 255, because that would mean there would be, if you took 255 and you divide it by 16, you would first get 15 divided in it singularly, which would be 15 16s, which would come up to 240, and then you would add 15 ones, which would make it 255, and that's how you would get your FF. So just for example, I'll just run this real quick. This is a finished sample here, which we'll be working on. And if I enter an RGB number of, let's just say 0, it would say 00 because we still want 2 digits, even though we're just putting 1 digit in there. So they still use 2 digits, even if there's just a 0. So we won't just put 0, we'll still put 00. So let's say a number is 16. We already used that one, so let's see if I was right. And it's 10 because there's 116 and 0 ones. And let's try 160 because I mentioned that up here in my comments. So that comes out to A0 because there's A 10 16s and 0 ones. And then finally, I'll do the highest one, 255, and it comes out to FF. So it's working. But what if somebody is a smart aleck and they decide they're going to put in a number higher than 255? Let's say they're going to put in 256. We have a little message that comes up and says use 0 through 255. So we're catching that. Now, we're not going to catch everything. We're not catching if someone types in a bunch of letters. There's nothing we could do right now because it's going to be converted to an integer since we're doing math. And if it's converted to an integer and someone's putting in letters, we're going to get an error unless we do some other kind of exception to try and catch it. But for now, we're just going to catch any number that is over the 255 in our if-else statements. And that's part of what we're doing here. We're using if-else statements so that if a number is 10, we're going to use A. And if a number is 11, we're going to use B, and so on. That's how we're going to convert these from being the regular numbers of 10 through 15 into letters, just like we did with the grades. So this is fairly simple of what we're doing here. So this will kind of finish off our if-else statement. So what we're going to do next is get started. Welcome back, CSE 121 W1. That was an older video that you were watching there where I was attempting to explain RGB and hex. Hopefully it helped. And I'm going to now start working on the exercise, and this is coming from Spring 23. So I'm going to go in Replit. The older exercise was done in Python Anywhere. So I'm in my folder for CSE 121, and I'm going to hit the Create button and make a new repel and use the Python template and call it 7. And I'll just put RGB hex. You could put a dash in if you want. And I'll put my initials. So it's 7 RGB hex. It's a conversion that we're going to be working on. And I'll create repel. And I have a brand new repel. Again, we're not working with any files or anything over here. So I'm going to close this up so we have more room and kind of move this over. And to get started, we're going to do an input so that we can input a number, an RGB number, and then come out with hex. So let's start with RGB. We'll make a variable. And what we're going to do is we're going to input, so let's put an input, and inside the prompt, for the input prompt, we'll put enter an RGB number, and I'll just put from 0 to 255, just so people do that. And I'll put a colon and a space, and then I'll add my quotes. Somebody mentioned in the forums that I do this and I then add the quote. I'm not sure why I do that. I just like to type it in and then just add the quote after. And I'll include the space, and you can do that in one shot, and I'll just make that a string. But however you do it, if you want to put the quotes in first and type it, that's fine too. So we're going to enter, and that should be end, it should be enter an RGB number from 0 to 255. So that's going to be our prompt. Now keep in mind that we're going to be doing math. So we're going to be dividing whatever number by 16, and we're going to be getting remainders, sometimes no remainders, whatever. But remember, when we're doing math, we want this to be an int, and right now it's going to come back as a string, even if you put in a number. So you can do two things. One is you can reassign it. You could just say RGB equals int, do the int conversion, and put RGB, and that'll do it. But that makes an extra line of code. If you want to do it on one line, you could just go up here and just convert it that way, and then make sure you put your parentheses around it, so you have double parentheses, so you have your prompt in the parentheses, and then the int is wrapped around everything. And then you don't need this, then you don't need that extra line, but that's what it's doing. So we're just doing it all together, and we don't need that now. So what we're going to do once we get that number is we're going to try and come up with a hex number. Now you remember, whatever number we put in, whether it's 0 or 255, we're going to have 2 digits and 2 numbers, and actually they're going to be 2 digits, but first we'll have 2 numbers, and we'll have to convert the 1 to a digit. And what I mean is, the first part of this is the number of 16s, and the second part is the number of 1s. So to do that, we're going to have basically 2 variables, and I'll do the first one, and I'll call it hex 16, because this is going to be the one. And what we're going to do is we're going to take the number, this RGB down here, and we're going to divide by 16. Now, we're going to use floor division, but I just want to show you something first. And we're not going to have any remainder. But if you divide, it always makes a float. It always makes a decimal, and we don't want to have a decimal. So we're going to use something called floor division. But just to see what happens, we're going to do this. I'm going to do hex 1, because that'll be the 1s. And I'm going to do RGB, and we're going to get the remainder. So we're going to use a modulus, which is the remainder of 16 going in that, not 1. So the remainder, 16 will go into the number, and that'll tell us the number of 1s. And then we're going to have an output to actually do that. So let's make some output first, and then we'll see what we have going on here. So I'm just going to put an extra space here, and I'm going to put hex, and I'm just going to put num, because it looks like they have something here already. I just want to put hex num, and you could put hex underscore num if you want. Just so we don't use anything that already is a used name in Python. Hex may be used, so I'm not sure. In another program, when I used Python Anywhere, it came in blue like it was actually a reserved word, so I'll just use hex num. And I'm going to say hex num equals, and I'm going to do something different. Instead of printing it out, I'm going to make a statement that's going to get printed out. So I'm going to say equals, and I'm going to use an f string. So you don't always have to use f string in a print statement. You can use an f string, just create one. So I'm going to put f and then quotes, and that's going to be an f string. And then what we're going to do is we're going to put our 2 variables right next to each other. So inside here, I'm going to put hex 16, And then right next to it, I'm going to put hex 1. And I want curly braces, not parentheses. That's why they weren't showing up in white. So this is fine. This is a F string, so this will be something that we can print out. So then after this, then we're just going to print out hex num. Now, why make a variable for that? Well, it'll make it easier if we ever have to have very long strings. Instead of putting them inside the print parentheses, sometimes it's easier to kind of generate what we need first, and then we just have to put one variable inside the print parentheses. So, if we're doing a lot here, maybe there's a whole couple lines, maybe a paragraph of stuff, and this way it kind of shortens it a little bit of what's going in there. So we're going to do that first. That way we're kind of figuring it out here, and then we're printing it. So that's fine. Just a different way of doing it, generating what's going to go in the print statement first, and then kind of simplifying it through a variable. Now, let's see what we have first. Just what we have. We have RGB. We're going to input something into RGB. It's going to get converted to an integer, meaning it won't be a decimal. And then we're going to divide it by 16. Now, we're going to use floor division, but let's just see what happens right here. Enter an RGB number. Let me try 255. And I got 15.9375. Let me do this. I have them together. Let me put a space here and find out, because it could be here. This 15 could be part of it. I could just be missing it. So let me try it again. And this is where we try to keep it simple. So I'll put in 255 and hit enter. There we go. Okay, I was missing that. The 15 was put right next to it. So we're getting 15.9375, and then we're getting 15. So the modulus is working because it is going to be 1515, except they're going to be eventually converted to letters. But this one should not be a float. This one should be the whole number. So we should have, this part shouldn't be here. So you could actually try and convert it to an integer, but what we're going to do is use something called floor division, where we put 2 forward slashes there. And what it'll do is just how many times 16 will go into it, and that's it. So let's just do that first. And let's try a simple number. Let's try 16. Like, let's say the number is 16, because how many times will 16 go into there? Once. How many times, what remainder will we have? 0. So it should be 10 if we do 16. So let's try that just to start. So let's run this with floor division, and I'll put 16. So what should happen is, if RGB is 16, 16 should only go in there one time, and there should be no remainder. So it should be a 1 and a 0. Let's see what happens. 1 and a 0. There it is. 1, 0. So that's working. And let's try the 255 again. Let's run it. And let's try 255. And we get 15 and 15. Except what we're going to need to do is convert 15 and 15. Actually, anything over 9 is going to have to be converted into letters. So we're going to have to use if-else statements to do that. So this is working. Now, we're only doing one value. And remember, RGB is 3 values. It would be like 000 or 0 something 255. We're just doing one number here just to get one part of it. But we could break it out then to get full RGB numbers if we need to. But we're just focusing on one number from 0 to 255 right now. One 8-bit number is all that we're doing right now. We're not doing full 24-bit, which would be, the 3 numbers is how you get 24-bit color. So we're just kind of focusing on the one 8-bit right now. And our numbers are working. So this is working. So again, floor division, and this is modulus, and they're coming out okay. We're generating an F string here, and then we're printing it out. And now what we want to do, instead of any number that's over 9, we actually need to convert to a letter. And that's where we need to do the A is 10, the B is 11, and so on. So we're going to do an if-else statement for that. And we'll do that in part 2. So this is okay right now. So in part 2 coming up, just so we could stop the video, because the first part of the video had all that stuff about RGB and hex. And what I'll also do here, one last thing here, is inside the quote, I'm going to put a pound sign. Now that pound sign will not act as a comment because it's inside quotes, meaning it's part of a string. So it just is treated as a regular, just like an F is treated as a regular F inside of here, the pound sign is treated as a regular pound sign inside of here. So it's not a comment or anything like that. So I'm going to go up here too and put an actual comment and put floor division and modulus division, just so I know what I'm doing there. And you could certainly look that up. That was in the last chapter in the How to Think Like a Computer Scientist book. But that's what we're doing right here. Floor division and modulus division with these two things here. So that's a perfect example to use that is with RGB, where you're trying to figure out how many 16s and how many 1s. So this is how many 16s, this is how many 1s. And if you want to put something here, and that kind of explains it a little bit. So in part 2, we're going to work on our if-else statements, and we're going to generate any numbers above 9 so that we always have one digit. We should not have 2 digits and 2 digits. We should only have 1 and 1. So we're going to have to change this. So this will be an F and an F once we do our if-else statements coming up.